Welcome to this video on fractions and decimals. We will cover the arithmetic groundwork for algebra, focusing on how to handle parts of a whole and express numbers with the right level of precision. In this video, you will learn to name and simplify fractions, perform calculations, convert between fractions and decimals, and apply judgment when rounding numbers. Fractions and decimals are essential in daily life. Whether you are cooking, managing money, measuring lengths, or working with scientific data, these concepts provide the precision you need. Our roadmap is divided into two parts. Part 1 covers fractions, including simplification and operations. Part 2 focuses on decimals, place value, and rounding techniques. Let's begin with Part 1, fractions. We will explore how to name, simplify, and calculate with parts of a whole, all without relying on a calculator. A fraction represents parts of a whole. The top number is the numerator, representing how many parts you have, and the bottom is the denominator, showing the total equal parts. Note that the denominator can never be 0. There are three main kinds of fractions. Proper fractions have a smaller numerator than the denominator. Improper fractions have a numerator greater than or equal to the denominator. Mixed fractions combine a whole number with a proper fraction. When classifying fractions, remember the minus sign rule. Ignore any negative signs and simply compare the sizes of the numerator and denominator to determine if the fraction is proper or improper. Fractions can be written in different ways while maintaining the same value. By multiplying or dividing the numerator and denominator by the same number, you create an equivalent fraction. To reduce a fraction to its simplest form, you must identify and cancel out any common factors shared by the numerator and the denominator. Remember, only cancel shared factors, do not subtract. Here is an example. To simplify 24 over 36, we prime factorize both numbers, identify the shared factors, and cancel them to find the simplest equivalent form, which is 2 over 3. You can also build equivalent fractions. If you have a target denominator, determine what the original denominator must be multiplied by, and apply that same multiplication to the numerator. The big idea when adding or subtracting is that fractions must share a common denominator. You cannot combine them directly if the slices represent different sizes. Use the common denominator method. Find the least common multiple, rewrite each fraction, combine the numerators, and then simplify the final result. In this example of adding 2/3 and 5/4, we find the common denominator of 12, convert both fractions, and add the numerators to arrive at 23/12. To calculate 4/9 minus 1/2 plus 5/6, we first find a common denominator, which is 18. Rewriting each fraction gives us 8/18, 9/18, and 15/18. Combining these yields 14/18, which simplifies to 7/9. Switching between mixed and improper fractions is essential. For mixed to improper, multiply the whole number by the denominator and add the numerator. Conversely, divide the numerator by the denominator to return to a mixed form. When multiplying fractions, multiply straight across, numerators together and denominators together. You can often make the math easier by canceling common factors between a top and a bottom number before you multiply. Canceling across a product is a powerful time saver. By canceling shared factors early, you prevent the numbers from becoming unnecessarily large, making the final simplification much faster. When working with whole numbers and mixed fractions, convert whole numbers into fractions by putting them over 1, and convert mixed fractions to improper fractions first. Then, proceed with the standard multiplication rules. To divide by a fraction, use the "invert and multiply" rule. Flip the second fraction upside down, turning the divisor into its reciprocal, then perform simple multiplication. When dividing fractions, remember to invert the divisor, not the first fraction. Applying this, 6/25 divided by 2/5 becomes 6/25 times 5/2, which simplifies neatly to 3/5. Fractions appear in many practical contexts, from scaling baking recipes and sizing DIY tools to financial calculations like splitting bills and understanding probabilities and chance. Let's put your knowledge to the test. Pause the video to solve these problems across addition, subtraction, multiplication, division, and simplification. Compare your results to the answers provided on screen. Now, we transition to Part 2, decimals. We will examine the decimal place value system and learn how to express numbers with precise accuracy. The decimal system continues the place value pattern established with whole numbers. Moving past the decimal point, each position represents a fraction of a unit, decreasing by factors of 10. Remember that each decimal place has a specific value, tenths, hundredths, and thousandths. A simple example is 0.25, which represents 25 hundredths, equivalent to the fraction 1/4. To convert decimals back into fractions, place the digits over the denominator corresponding to the last decimal place, like 10 or 100, and then simplify the resulting fraction. Some decimal fractions appear so frequently they are worth committing to memory. These include the common quarters: 0.25 for 1/4, 0.50 for a half, and 0.75 for 3/4. When converting fractions to decimals, ensure you account for every decimal place. If a position is empty, use a 0 as a placeholder to maintain the correct value. The big idea in measurement is precision. You should state a number to the exact level the task requires. No more, no less. We use significant figures and decimal places to control this accuracy. To round to significant figures, look one digit beyond the number of figures you need. If the next digit is 5 or more, round up. Otherwise, round down. Remember that leading zeros don't count. Rounding can cascade. For example, rounding 999 to one significant figure turns it into 1000. When digits roll over, ensure you maintain the appropriate scale. Understanding rounding intervals helps determine the original range of a value. A number like 67, rounded to two significant figures, implies an original range from 66.5 up to, but not including, 67.5. Decimal places count only the digits after the decimal point. The rounding rules remain the same. Look at the next place over to decide whether to round the target digit up or down. When rounding to decimal places, if your rounding requires a 0, keep it. Writing 2.0 instead of 2 shows you specifically intended to round to one decimal place. Significant figures and decimal places serve different purposes. Significant figures describe the overall scale and meaningful precision, while decimal places focus on exact positions after the decimal point. We use these tools in various applications. Money requires 2 decimal places for currency, science relies on significant figures for accuracy, and engineering uses fixed decimal places for tolerances. It is time to practice. Try converting these values between fractions and decimals, or rounding them as requested. Work them out yourself before checking the results. Watch out for common traps. Don't add denominators. Avoid canceling across plus or minus signs. Remember to write trailing zeros in decimals, and ignore leading zeros when counting significant figures. This is your playbook for choosing the right move. Whether you are combining fractions, switching between forms, or determining the correct precision, refer back to these core principles. Keep this fractions toolkit handy. It summarizes how to simplify, perform arithmetic operations, and convert between mixed and improper fractions. Similarly, this decimal toolkit covers your conversion methods, the definitions of significant figures versus decimal places, and the fundamental rules for rounding. Finally, here is a quick test of your knowledge. These 6 problems cover both chapters, giving you an opportunity to verify your mastery of these concepts. In summary, fractions and decimals represent the same numbers. Common denominators enable arithmetic, place value bridges the two forms, and rounding ensures your answers fit the precision needed.